Hello everyone, welcome to the IEEE Communication Society podcast episode number 20. This is Professor Aryan Kaushik from Manchester Met in the UK, host of your podcast series for IEEE ComSoc. And today I have with me very esteemed guest and my friend, Professor Wonjea Shin from Korea University in South Korea. And if you remember, if you recall, we have done a podcast before together on Non-Terrestrial Networks from Malaysia. Today we are in London, very sunny day, good weather, right, Wonjea?
Yes.
Right?
It's very good weather and
it's sunny,
yeah,
right?
it's very sunny.
And here we are to discuss about two of the latest technologies that are going to be part of the 6G framework, or let's say 6G infrastructure that we are talking about. Namely integrated sensing and communications, and also non-terrestrial networks, and also the amalgamation of these two technologies. So this is what we are going to talk about today. So with this, welcome Wonjae to our podcast, firstly.
Thank you for having me here, and it's
so good to have you here. Yeah. So maybe Wonjea, we can start with something on the sort of 6G framework that we have, the IMT 2030 framework, as I, like always talk in my podcasts. So we have these two technologies, right, with ISAC and, sort of non-terrestrial networks and to provide ubiquitous connectivity. Then we also have the integration of AI and communication. So these are the three enhanced capabilities we have in addition to what we have had for, let's say, 5G and, advancing our immersive communication, whatever, hyper reliability, low latency, and other sort of sustainability aspects and so on. So several of these things we have, keeping massive connectivity in mind, right? So perhaps we can touch first on sensing and comms. So what do you think about this joint design of sensing and comms? Have you got any ideas floating around in your head? Why this technology is important and why we are going to implement ISAC for 6G, let's say?
Yeah. I think sensing could be a very important role for the 6G era. So most important thing is, I think, the mutual benefit between the sensing and communication. For example, we could think of like a sensing assisted communication. For example, if we use like a millimeter wave or higher frequency band, it has a lot of the line of sight link should be secure. So in that cases, if we know about where is it located of the users are located, then so that's through that can be done by the sensing from a base station. Then with the information of location, base station can design the beamform more efficient way. So that's one part. But also in the other hand, also communication can benefit to like a sensing. For example, like a non-line of sight sensing. So in the radar we should have some line of sight link toward the target. But if we have like a communication like a function. So let's say if we have a relay and we don't have a line of sight toward the target, in that cases, like a relay can help to the sense the target, which has blocked it by some obstacle, but still that we can do some non-line of sensing. So I think that's a very important mutual benefit between sensing and communication. That could be happen for the 6G.
So in standards, I think we actually included sensing and comms, especially in 3GPP release 19. So the one that you're talking about, communication assisted sensing and sensing assisted communications.
Exactly, yeah.
So there are like some early system aspects and study items around these. And the good thing is they are all around these industry use cases, right? For functionality requirements, we have 32 industry use cases predefined for different applications, like in public safety, in agriculture applications, environmental monitoring, or motion tracking, or even for like robotics, maybe using like automated guided vehicles and so on. So I do think that sensing and comms is quite going to play quite an important role into 6G and beyond. Would you like to touch a bit more on what kind of like applications it can support for sensing and comms?
Yeah, I'd say for example, for me, I have a lot of interest on the NTN or the LEO satellite communication. So the LEO satellite also has a lot of opportunity to do some sensing, like such as a radar or the SAR system, like a radar imaging system. So I think with the same, the unified like a waveform, we can do both sensing and communication. So I think also in the sense of the radar or sensing, like a satellite has a very good coverage. So I think also like a non-terrestrial network can also provide a good coverage for the sensing and communication. So Aryan, so what do you think about the benefit of the joint design of the sensing and communication?
Yeah, Wonjea, I think you discussed definitely about the applications part, so that's a good thing. But some people also have to understand why we are actually doing sensing and communication together, right? So we are talking about integration of sensing and communication. Some people are also saying unification of sensing and communication, right? So the basic idea has been, let's say a couple of years ago, when we started, again, it's not a very new idea, but for 6G perspective, it has picked up now. So the idea was to kind of save on your spectral resources. So basically to use the same frequency, for both sensing and communication when you're trying to do this dual function signaling, let's say. So instead of using, let's say 3 gigahertz for your radar sensor and maybe 4 gigahertz for your communication equipment, right? So basically you utilize one single frequency, 3.5, 3 gigahertz or whatever that is, right? That is one thing. So you want to decongest the crowded spectrum that we have with the microwave spectrum, right? The sort of sub 6 gigahertz frequencies we are using. At the same time, utilize the same hardware as well. Okay, when people came out with the idea of ISAC, they were saying, let's do some sort of coordination between these two different devices. So maybe you have a radar sensor in one side of your room, maybe a mobile equipment on the other side, other corner of the room, and basically they coordinate with each other and to provide the common output, right? But you can go one step further. You can have a dual functional signal implementation. So your signal that you are transmitting, so you share the same hardware for that, and basically they have both the information. So they are basically able to detect any objects, targets, and at the same time they are able to communicate information with the mobile users as well, right? Yes. So need to play around. How would you do this? Is it simultaneous dual function signaling, or basically it can be one after other? Like, are you doing some sort of duplexing, or I really need to think like how would you amalgamate these two different operations together? So the main idea has been to save on the spectral resources and hardware resources. That is basically the main aspect of utilizing ISAC, the main idea. Then, as we were discussing, I mean, it leads to loss of applications, as you have mentioned also on NTN and other things. So in my opinion, the most important sort of application that we have, or use case we have, is in public safety, right? So you have basically in disaster management scenarios. Unfortunately, if a disaster has happened, right? Yeah. So in southern Turkey, a couple of years ago, unfortunately that happened. So in those scenarios when all the infrastructure is broken, so in those scenarios, what you do is you need to actually, detect any objects, any stuck cars, or any stuck people, or like anything that you need to actually sense, right? Yeah. And at the same time communicate that information as well, right? Even with the users on the ground, or maybe relay that information to some other base station or control center unit that basically can monitor the situation. Here, non-terrestrial networks play a very big role too, in addition to sensing and comms, because you can send in your swarm of your drones or UAVs basically to monitor the situation, or kind of relay the information back to some other base station, even satellites, right? So you can take direct access from a satellite on your ground, and basically you can use the dual functional signaling to sense and communicate information at the same time. So that brings me to further discussion with you, because you're an expert in non-terrestrial networks, right? So the idea is, okay, I'm talking about the amalgamation of ISAC and NTN. What do you think about what have been the latest advancements in both the fields, right? So especially in non-terrestrial networks, right? What do you think, what you have been working around, let's say in recent times, that you would like to share with us, Wonjea?
Yeah, so this day I'm working on the LEO satellite communications. So in that and in that area, I think the most important the challenge would be interference management,
right?
Because the one in the sky or the space provide a very good coverage, but at the same time, also it can ruin the existing terrestrial system. So I think interference coordination between the terrestrial and non-terrestrial would be very important. And also there is already the well established GEO system. So if we develop a new like a LEO satellite based network, it has also conflict each other existing GEO system and new LEO satellite system. So also we can work on some multi-layer like interference management system.
So how does that work, multi-layer interference?
So usually the existing like industry such as Starlink or OneApp, they also come up with some idea of how to cope with this interference toward existing geo, but all this is based on like interference avoidance. But in our group, so we are trying to come up with a very new idea on how we can coexist between a LEO satellite and geo without like a partitioning the frequency over the time. So that's I think a very important idea how to support rear ubiquitous connectivity.
So is it something related to mega constellation NTN?
Exactly.
Is it like something similar to that? Like you have different, inter-satellite links,
Exactly.
but through LEOs to GEOs,
Exactly.
perhaps,
Yes.
and then you have a joint connectivity that you send it on the ground.
Exactly.
To complement the, the
Exactly.
operations on your
Exactly.
terrestrial network,
Yes,
right?
yes.
And here we have very good solutions, right? I mean, based on edge cloud computing, let's say.
Exactly.
So when you try to, implement some sort of AI algorithm, maybe for resource allocation, resource management, or something like that. So I know your group has been like really active in sort of utilizing sort of multiple access frameworks and approaches.
Yes.
In our group, we have been working more on the AI side of it, like how can you enhance the performance and the sort of lower down the delays, the latency. So how you achieve lower latency at the same time keeping very high energy efficiency of the whole operation when you utilize, I don't know, some deep reinforcement learning based methods, or even maybe federated learning like people are trying to talk about now, or quantum federated learning that is coming up, right? So in terms of interference management that you are saying, so what kind of techniques we are utilizing Wonjae for these joint systems of integration of terrestrial, non-terrestrial networks?
Yeah. So for me, this day I'm focused on the rate splitting multiple access and its application on the LEO satellite communication. So as I mentioned earlier, also there are many different types of interference arising in NTN. For example, LEO and GEO, they usually create multiple beam transmission. So inter-beam interference should be the first type of the interference. And the second type would be integrate satellite and terrestrial network, in short ISTN, and also the multi-layer interference between multiple like orbit of LEO or LEO or GEO or LEO or MEO or LEO or UAV. There are lots of different layers in NTN. So imagine now at this moment we have a 7,000 LEO satellite, even with the Starlink launch at this moment. So if they don't have a coordination between the LEO satellite, it has a lot of it induces a lot of interference problems. So I think rate splitting can also play a very important role in solving the problem of many different interference arising in LEO.
So I remember we had talked about rate splitting, multiple access in our previous podcast that we did together. I want to move a little bit, maybe one step further. So recently we are also coming out with some sort of usage of intelligent meta surfaces, right? And basically having combined index modulation, the concept that we have, how we embed information at the transmitters, right? So that we don't require any decoding on the receiver side any successive interference cancellation unit, right? That we call it. In case of rate splitting, I know that you do partial decoding, right? Because of you are decoding your signal for
Exactly.
common streams and like only once and private every single time for individual users.
Exactly.
Compared to NOMA, let's say, non-orthogonal multiple access, we need to decode it fully. So now the new concept that is coming is to utilize, some sort of intelligent meta surfaces, whether it's holographic MIMO, holographic beamforming, or utilizing with reconfigured intelligent surfaces or stacked meta surfaces. You want to pick just few of these unit cells out of the last surface, or in case of stack, just few of the layers out of the whole stack that you got of this large system, and combined with index modulation, right? Basically to intelligently pick just few of these unit cells and so on. So do you think that can be the future, is basically to implement, to save on this sort of interference cost that we have, basically utilizing these different degrees of freedom with meta surfaces doing the transmission? So we are talking about tri-hybrid beamforming now, right? Like you have hybrid beamforming, the conventional one, and you got the analog beamforming, plus you got additional meta surfaces layer next to the antennas. And then basically combined with index modulation, you try to come up with this new multiple access framework. Do you think that is the future?
Yeah, I think that's a very good point. So, although we have a very good MIMO technique, but like a satellite system has a very limited power. It's a power hungry system. So we can't have a large number of the RF chain as in a terrestrial network base station. So we can apply for many different meta surface things, or the LIS or index modulation to design a beamforming in a very efficient way. So of course, a stack intelligent meta surface can be used for creating a very complicated pattern with a very limited number of RF chain. So in that cases, we can also design for like a frequency dependent beamforming too. In that cases, so we have a very drawback for the phase array antenna we often use in the LEO satellite, and also the gate the ground station for the LEO satellite communication. But so one drawback of the phase array antenna is they can focus on the one direction for over the all frequency. But if we can design like a frequency dependent beamforming using the stack intelligent meta surface or holographic MIMO or any other different types of the kind of the list, including block diagonal list or many other different
beyond diagonal.
Beyond diagonal list, or with this kind of a new kind of technology, I think we can design for advanced beamforming technique for LEO satellite communication.
That sounds interesting, because the thing is, let's say if you're operating at high frequency scenarios, I think RIS or these kind of meta surfaces are very useful, especially holographic if you want to also save on energy. Because as you said, satellite has already got high payload, right? Now you're adding up some AI methods, you're adding up all these algorithms and all these chips and all that to make it even heavier. It's not so cost efficient. So perhaps in terms of beamforming, you may need to come up with these nice ideas, with holographic beamforming, let's say, where you can, save on the energy cost and so on, or some sort of optimization of RF chains and so on that, we use on board on the satellite. Or maybe you can have some sort of portable solutions that you plug in when you actually need them. Perhaps on the satellites. I don't know how cost efficient or inefficient that may also get, but I think that is also one direction we can think about to kind of save on the energy, through physical layer techniques or through different network layer techniques and so on. And also we are trying to do this integration with the terrestrial network, right? So it is very important that they are in coherence, not just in spectrum side, like you are utilizing same frequencies or adjacent frequencies, but also how you design them. So I think, in my understanding, we need to do changes in both sides a bit to kind of have this coordination to save on energy and on our latency and spectral size. Like people now use amplifiers and so on, but that is another cost to think then, because if you use amplifier, because LEO satellites are quite far from the ground, so you need to amplify the signal to reach to the ground. Perhaps you can use meta surfaces and this index modulation everywhere, maybe on the satellite, different satellites. You can reach between satellites, maybe LEOs and GEOs as well. They can utilize these meta surfaces and kind of reflect and transmit the signal. And at the same time on the ground too, and maybe with the layer in between with the drones or hot air balloons, HAPS, that we are trying to think about, right? So here you also plug in some meta surface and index modulation together. That also saves on, combined with index modulation, something on the interference management side, I think.
Right. So these days, I think the mega trend of the LEO satellite communication is like a connectivity. I mean, provide a connectivity to like an unmodified smartphone. So that's I think the new thing. Also in Starlink, they call these services as direct to cell. And so with your unmodified phone, we can, our phone can get access from like a LEO satellite communication.
Yeah.
Then the problem is how they can combat very large pathways. So Starlink, they changed their orbit from 500 kilometer to the 300 kilometer.
All right, so even closer, yeah.
Closer. And AST Mobile, so that's also one of the largest LEO launch company. So they launched the LEO satellite with a very huge phase array antenna. So most of the burden to combat this the large pathways is to put. Put to the satellite. We used to have a very large, the phone, satellite phone, right? It's a huge phone to connect the satellite we used to have. But this day, the trend is with the unmodified phone, how we can connect to the satellite. So satellite has to have a very, the large phase array antenna with a very high gain. And also they has to come closer to reduce pathways.
That's interesting because generally people have been utilizing satellite connectivity for these emergency SOS services. But are we talking more on the commercial grounds now? That because this is going to be a part of the 6G infrastructure, right? So do you think that is the way forward? Is that how you place satellites much closer and also to achieve larger gains, in terms of phase array antennas and so on. So that is something going forward.
Yes, yeah. I think even the 3GPP NTN standardization. Also, they have a two-track. One is with a VSAT terminal, so which is a special a terminal for the satellite communication. But the other one is that the terminal is target for just smartphone. So we have we consider two different scenario for the NTN. So I think more popular scenario these days are direct to cell, which is the connectivity with the smartphone.
And then how do we place this layer of these, let's say UAVs and drones and HAPS that we are talking about, these high altitude platform systems? Don't you think that is more like a complementary to the satellite connectivity?
Yeah.
Or it is going to take over much more than the satellite connectivity? What are we thinking? Or like a balance of both?
Yeah, I think they have different roles in terms of connectivity. So usually the UAV has a much more freedom to design their a path and trajectory. So they have a more optimizing. Yeah. So if they have some traffic demands are increased, then instantaneously the UAV can go there and provide a service their services. But the LEO satellite has a more a wider coverage, and also it's orbiting in a regular manner. So I think that's a more stable connectivity for the global coverage. So I think they have a complementary
right.
manner.
But there is one more thing, because there is never a free lunch, right? So let's say in drones, the problem is that they run out of battery. Let's say if you're operating for disaster management scenarios, you need them for longer, right, to do these search and rescue operations. So in those scenarios, maybe in 24 to 48 hours or something, after that the battery dies down. So I think we did come up with these kind of solutions as a community to basically provide these lasers, right? So you have this free space optics that you use. So you throw in the laser beam and basically charge them. You keep them charged for as long as you require the operation for. Is this something similar for satellites? How would you make sure that they are always in operation, and at the same time the coordination is always there? Because I'm afraid, because in when you are talking about connectivity between drones and satellites, and basically providing a sort of integrated connectivity to the ground user in marine areas, or maybe like remote areas, or even disaster affected areas. So how would you ensure is that this is always maintained, especially in public safety scenarios?
Yeah, so to cover like a global coverage, we need to have a large number of the satellite.
Right. So there's multiple
Yeah,
satellites
exactly.
required.
Just one or two satellite cannot cover the global coverage. So so if you have enough like a satellite, like a mega constellation, then we can also guarantee that there is no like coverage hole. Yeah.
But isn't it problematic in a way is that all these satellites you might have assigned to some other tasks, and now you want to utilize it for something like emergency response or something? Wouldn't the other tasks be impacted? And how would you make sure
Yeah.
that the other operations are also going on at the same time?
So like a load balancing, across mega constellation would be also very important topic. So there are lots of demand, different heterogeneous demand from the ground. So I think the very important thing to do, tackle. I mean, the challenge we have to do is how to like manage and optimize the many different like a traffic load and a workload. And how to design and like that kind of thing should be very important. Tackle, what you have mentioned.
So how would you make sure that this is cost efficient, by the way?
Yeah.
That is one question that I always have.
So in that sense, what is AI can plays a role in this setting?
So our group works around, so that's why I was interested to know. I mean, you can manage this, resources like you utilize maybe through like edge cloud computing, perhaps, as I was mentioning. So you have all these inter-satellite links between maybe all the LEOs, or maybe even LEOs and GEOs, if you're talking about mega constellation NTN. And basically you store some information that is computationally inefficient. You don't require right away. You store on the cloud, and then basically you run some sort of optimization there. And AI algorithm, of course, DRL, federated learning, quantum DRL, quantum federated learning, or whatever is the approach that you want to utilize to basically enhance the energy efficiency of the whole overall system, at the same time lower down the latency. So we had assumed maybe in our works is that you basically keep the same 1,000, 1,500 kilometers for your satellite, so not like coming too close to the Earth's surface, but basically you're mentioning that is also one idea that we can approach, perhaps is a better idea. And basically instead of more let's say spending your resources on the optimization, perhaps you also need to work around the physical placement of your flying platforms or your satellites and so on. So that probably maybe like a good solution going forward. So that is good, Wonjay. I think we discussed quite good points. So before concluding the podcast, would you like to touch on any future works or any future improvements? I know like you and I also work quite a lot together on all these techniques and all these new ideas and so on. But I would like to know your thoughts.
Okay. So I think we can like think of many different new the dimension for upcoming LEO satellite network. So for example, LEO satellite, it has evolving with a very high speed. It's 7 kilometer per second. So it's corresponding 27,000 kilometer per hour. So it produces a lot of the Doppler. But also Doppler is a function of the elevation angles or relative velocity. So in our group, very recently we are trying to come up with a new idea of the Doppler-based positioning. So without a GPS, how we can make use of the mega constellation of Leo with the Doppler. So we try to play with the Doppler for our like new resources for like localization and positioning. And also at the same time, we also look at how the Doppler can be our new resources for multiple access too. So I think those kind of direction should be very important. So it used to be a very like a detrimental effect for communication, but in the future we can play with this for the new multiple access or new sensing or new like functionalities. So I think that should be the very important.
Very nice, and it also adds to some more, user scenarios. Maybe you can bring on board localization,
Exactly.
positioning, or some sort of another form of tracking.
Exactly.
You can come out with.
Yeah.
Even for robotics, I mean,
Exactly.
to be honest, we're utilizing a lot now.
Yes.
It's a very niche area, by the way, utilizing sensing comms and maybe satellite-based connectivity for your robotics application. But I think this is a good idea to also think about. I don't know how you can compensate for Doppler shift in a very efficient way. Have you got any idea on that?
Yeah, so I think you and I we already published one paper
Yeah.
on how the list can like compensate the Doppler the causing by the LEO satellite. So it's a quite efficient the way to compensate the like a list on the other LEO satellite on the or installed in the building can compensate the Doppler shift so that the user can just can get a receive signal without a Doppler. So I think that could be also very interesting. But in the other hand, also like with a meta surface, like a holographic MIMO or other like a technique also can compensate the Doppler shift, because Doppler shift is a change of the frequency. So we can design a phase shift, but over time we have to change over a phase shift over time. So that can mitigate the Doppler shift. Causing, arising in an NTN scenario. So I think that could be also one reason why we have to focus on the list or advanced list in NTN scenario too.
But we have a bit of debate going on, by the way. Should we have race or should we have the, keep the repeaters and
Exactly.
relayers that we have been using?
Exactly.
But the good thing is that we are coming out with these new technologies like holographic beamforming and stacked meta surface, flexible meta surfaces, or meta prism is also another good one. Our friends work on the fluid antenna systems now, adding another layer to
there are a bunch of the new antenna systems.
Yeah, so all our friends working around this. So we're promoting our joint works and their works and so on. So that's a good thing. And I think it has to be combination of all these things combined together. Like you have AI, you have sensing comes together, you have NTN based connectivity, and also making sure that these solutions are sustainable enough. They are not just like that you're working towards massively connecting the devices, massive IoTs and so on, like different applications. But at the same time, they're energy efficient, green, they're immersive too. At the same time, they're intelligent too. Like you should have the choice. How many resources I already have? How many I'm going to use? Even on a smaller scale, like how you optimize your RF chains, quantization units, and so on. How you optimize the layers of your meta surfaces or the unit cells of meta surfaces. So it becomes very important that you combine everything together. Complex scenarios, but also work around how to make them more efficient. To sort of work together.
In that sense, I think the AI can play a very important
Yes, but you need to think about how accurate your solutions are and how well trained they are.
Exactly.
So you cannot like roll out, let's say, AI-based algorithms like unprepared. They have to be mature enough. That's why even on the AI side, especially for communication applications, we are working around new sort of variants of machine learning algorithms. Right. So now LLM is coming up, large language models, and how can you enable different technologies like ISAC and NTN and all of that using maybe LLM models and so on. Gen AI is, very useful at the moment. Generative AI, how would you utilize those, different aspects of generative AI, right? And of course, you're adding up quantum theory too, in addition to what we already know. right? So deep reinforcement learning, we already know, let's say. So you have quantum enhanced DRL. So one of the papers we published recently in JSAC Wonjea was about that you have quantum enhanced DRL, but you use it for, ISAC, NTN, and RIS, all of this system combined together. Very complex scenario, by the way, but this is also one direction I think I quite relate to kind of, enhance the performance through utilizing different variants of machine learning algorithms. So I fully agree with you, but also we need to add up some, you need to include some additional things to these aspects.
Okay.
But with this, thank you so much, Wonjea, for being here. I really enjoyed our conversation.
I really enjoyed it too.
And hopefully we can have more podcasts later on,
Okay.
maybe in Korea,
Yes.
in Japan perhaps.
Yeah.
So Wonjea, you and I are traveling to Japan, so maybe we can, think about something.
Okay. Next month we can
Next month, exactly. Okay, but with this, thanks a lot.
Okay, thank you.
Thank you.
Thank you.